Alrighty. Hello, everyone. I don't think we have everyone, so hopefully people will trickle in these next few minutes until we get started with the actual material. But until then, I'm just going to go over a few things. Welcome back to my session, first of all. Again, it's been 2 weeks, so yeah, we keep missing each other a little bit, but it should get a little more steady from now on. So you should expect this week we're doing lab 3, of course. Next week we're going to be doing lab 4, and then the week after that, which is going to be the 27th, we will have 28th actually, we will have our next quiz. So get ready for that. I wanted to actually mention, thank you for turning on your cameras, everyone who's done that. And I want to mention a little bit about the quiz. So let me go ahead and share my screen real quick. Everyone can hear me, right? Yes? Okay, great. Share screen. Yep, okay, cool. Share screen. Okay, yes. So I want to talk a little bit about the quiz and a few questions that I've had over the weekend. Thank you to everyone who's emailed me. That is definitely going to be your best way to get in touch with me if you have any questions about the quiz. If you haven't yet emailed me and you have a problem with something about your quiz, or you want to just come talk to me in office hours tomorrow, that would be completely fine. Office hours are from 3 to 4 tomorrow, and then from 11:30 to 12:30 on Friday. So if you have a question about anything that I can help you with, if it's just going over the problems, or how do I study, a logistics problem, anything that you would like to discuss, either an email or office hours works completely fine. If those hours don't work for me, just shoot me an email and we can figure out something that will work. I also want to mention a few kind of minor but major things that I think everyone should be aware of. There are good points that were brought up by a few students. So number one, when you're filling out the quiz, I hope you kind of got the idea of what you're expected in terms of what types of questions you will be looking at. There is a wide variety of questions, and it is a fast quiz. When you are answering the questions, it's really important, obviously, to read the question really thoroughly and see what they're asking you, right? So if they're asking you about the structure, but they are giving you an image, then make sure you don't write what that structure is, because that's not the question, right? They're asking you what the function is. So just be cognizant of what the question is asking you. If you put part of a wrong answer and part of the right answer, that is still the wrong answer. There is no partial credit, so just make sure that you're answering exactly what is asked for. It's really hard for us to grade you if there are some correct bits to your answer and some incorrect bits, because then we don't really know what you know. So if you can just be really clear about what you are understanding from the question and read directly what is being asked of you, then that'll benefit you all as well when you're answering questions in the quiz. And so another question that was brought up was that the feedback had disappeared for a few days. So we figured out that question. So hopefully that is all situated. I know I had sent someone to ITS, and hopefully we don't have to do any of that anymore. Dr. Schutz figured it out. So if you were trying to check your feedback over the weekend and it kind of just disappeared for a few days, that is why. It should be back up now. Just make sure you've gone through the entire quiz and you really understand what's going on, what questions you missed. This is not going to be the last time you see this information. This is not even the last time before the final that you see this information. We're going to keep building on what we've learned in our next few labs. So it is really important to know the information and not get behind on that. So again, if there's anything that I can do to help you prepare for the next coming quiz, or just anything related to the class, doesn't have to be related to the class, whatever you'd like to do. Office hours have been kind of lonely lately, so if you would like to stop by and chat, that would be great. Alrighty, I think that's about all for the logistics. This is a pretty short lab, so I'm hoping that means that we can have plenty of time to do the Kahoot. And what we'll do this time is we'll have the Kahoot in our main session, and so I will be here in the session. And if you have a question that you need me to answer, or if you want to go over your quiz or anything of that nature, then we can hop into a breakout room and answer your questions there. But we'll be doing the Kahoot in the main chat. So hopefully, if you can stay, that'd be great. Shouldn't go past 8 o'clock today at all for the Kahoot as well. This is a pretty short lab, and I'm hoping that means that we're able to grasp the information well and that you all have had some time to look over it. So, all right. Any questions before I get started about the logistics? Anything to expect for the next quiz or questions? Nope. Okay. And of course, you all know that you can always stop in the middle of lecture if you just raise your hand, or if you write something in the chat. Annie will be helping me out with that. And at the end, if you have a question that you'd like to discuss more, we can do that in private in a breakout room. Alrighty, let's get started. So today we're jumping right into the skeleton. We talked a lot about the nervous system in the last two labs, and kind of feels like it took forever to get through the nervous system just because of all the breaks that we had. We're already in week 5 or 6 with some of these other classes, but we're just now starting our second unit. So that's okay, but hopefully now we know the nervous system super well and we're ready to build on it. So skeleton is broken up into 2 types of skeleton. So this unit we're talking about the axial skeleton, of course, which is going to be the centrally located skeleton. And then next we'll be talking about the appendicular skeleton, so our legs and our arms. So in general, the functions of the skeleton, the skeleton is very important, as you all know. So one of the most important functions is obviously the support, right? So our body needs something to help carry the weight, protection. So a few of the different things that the bones protect is the bone marrow inside of our bones, our brain, spinal cord, and visceral organs. And I think this is a majority of what the skeleton actually protects. If you think about the arms and the legs, we're not really protecting as much, but we're more using this third function, which is movement, right? So we're moving the muscles are going to be acting on the bones for motion. And then lastly we have bone formation. So red bone marrow will produce the red blood cells, white blood cells, and platelets. And of course, we know that that's very important. We don't talk a lot about the physiology in this class. This is just kind of a short overview, but you all will talk a lot more about it in your lecture if you're in that right now. If you already had it, then you already know. But there is a lot more to the physiology of bones, of course, but this is what we're going to kind of cover in this class. Okay. So we're going to do a quick recap of a few things that hopefully you recalled from your reading. So we're going to jump into some poll everywhere questions. So this first one is, which of these is not part of the axial skeleton? Just go ahead and respond to either this URL or you can text this number. And I'll go ahead. I think the timer worked pretty well for us, so I'm going to do that again too. Oh. Okay. So hopefully this was nothing too bad, just a quick recall from our reading.
Hey,
So
Zora.
hey.
Oh, please, I couldn't I'm still trying to log in. Can you please
Oh, yes, I can.
And I need the username as well, please.
Yep.
Thank you so much.
Let me make sure, did everyone? Yeah. So I have 24 responses, and then how many people are in here? 27. Okay. So we're waiting on 3 more people, is that right? So 2 more, because I have 25 responses now. I'll give you a few more minutes to get this all situated. Thank you for that, Dee Dee. All right, we have 27 responses. Perfect. So I'm going to go ahead and lock this now. So yeah, so like I was saying, this should hopefully not be too bad of a question, but for some reason it's a little tricky still to think about what the axial skeleton could involve. So when we talk about the axial skeleton, we are talking about this central location of our skeleton. So like I said, excluding the legs and the arms. But what does that actually entail? So definitely includes the skull. That is definitely going to be a major part of the axial skeleton. The vertebral column, again, another major part of the axial skeleton, and we know that it protects our spinal cord, so it's going to be very important. Ribs, so the ribs are also going to be part of our axial skeleton, and they're going to protect our visceral organs. Then we have our sternum, which again, part of our protection of our visceral organs because there's an attachment for our ribs. And then lastly, we have pelvis. So pelvis is actually going to be the correct answer. Let's see how we did. We have 89%, perfect. So not perfect, but you know what I mean? So we're doing well in our reading and recall. This would be a pretty good question to make sure that you are understanding just the overall functions of the and parts of the axial skeleton. Okay, so we have one more here. So which of these is the term for an elevated surface on a bone? So you were asked in your lab text to make sure you looked at the different terminologies. And the reason that this is going to be really important is because as we talk about the different bones, especially in the appendicular skeleton, by knowing what these different parts mean, you can kind of put into, you can kind of understand what their function might be, even if you didn't actually know what they were. So it's going to be really important to know these different terminologies. I think there were like 9 of them in the beginning of the lab text. So make sure if this is kind of looking a little foreign that you go over it again at some point. Hopefully it's not though. Okay, we're waiting. Oh, I'll open it up one more time for those 2 people. Yep. Okay, so just make sure that we get it in those in the timer. So the timer is gonna be 30 seconds, and you all can see the timer. Is that right? Someone give me a nod or confirm that you can see the timer. Yeah, you can see the timer. Okay. So yeah, so just make sure you can get it in that amount of time. That'll keep our keep it short. So yes, we'll lock this now that we have 27 responses. So the term for the elevated surface on the bone is going to be process. Looks like we really understand this concept, which is great. Can I get a volunteer to actually tell us what you might group fissure, meatus, and foramen as? If you were to put them, if you were to give them one overall term to describe them. What might we think? So fissure, meatus, foramen, and we have different words, different structures in our lab that use these word parts. So thinking back to those, what are they describing?
Openings.
Julia, I think raised her hand. Julia Logan.
Is it a depression?
Is it depression? Yeah. Depression could be, yep, depression could be a way to describe it. Kristen, were you gonna say something?
Oh, I was gonna say depression as well.
Depression, okay, great, yeah. We can even say something as simple as hole, right? Because each of these also describe holes. So depression, hole, something that goes inside, right? So it's not elevated, opposite of elevated, perfect. There is my mouse, okay. All right, so one of the main topics that we talk about in Lab 3 is going to be the structures of the cranial skeleton, right? And if you got to that portion in the lab text and you're reading through it, it might have felt a little daunting. There's that big page of all these different vocab words and all these different identifications that you need to make for the cranial skeleton. And in order to make sure that you don't get overwhelmed by it and you keep everything nice and organized, especially when you're first learning it, I really would recommend you're grouping your understanding of these different words. So of course the lab text does a great job of just putting like terms on certain pages and really creating those connections between these different words. So we're going to go over a few of these different pages from the lab text. And if you have any questions while I'm going over them, please do raise your hand or just go ahead and shout out your question. You can also write it in the chat. But I want to make sure we spend a little bit of time on the cranial structures so that we understand what we need to know and maybe where we have a little bit of a few questions right now. The first one that we're going to go over is the major structures of the cranial cavity. So here's a picture of the cranial cavity, of course. And if you were looking at this picture, what kind of plane has been cut to see this image? Does anyone know?
Transverse.
Transverse, exactly. And then what is our angle that we are looking at it from?
Superior.
Superiorly, exactly. So we are not looking at it from the bottom, we're looking at it from the top. Exactly. So this is like if I cut my cranial skeleton right down the transverse plane, and then I just took off this little hat, and that's what you'd see. So here, what you can imagine is the brain is sitting into this little cavity. So we create these fossa in the cranial skeleton, and they house the different lobes. So they're named quite appropriately. We have the frontal fossa, the temporal fossa, and the occipital fossa. And this is where those lobes will be situated as well. Then we also have two other key structures that are related to different bones that we will talk about on the external side of the skeleton. So one of them is going to be the cribriform plate of the ethmoid. So the really interesting thing about the cribriform plate is that it actually has these little holes, these little indentations It is the passageway for the olfactory nerve. And that kind of feels a little weird, like the olfactory nerve is going to pass through these many little holes. Well, to help you understand that a little better, here's a picture of what the olfactory nerve looks like. So it is actually branching through this cribriform plate of the ethmoid, you can see right here. And these cranial, the little branches of the cranial nerve of the olfactory nerve, they'll receive the smell, they'll pass the olfactory bulb, which we looked at in lab 2, then it'll pass down the olfactory tract and into the appropriate part of the brain where it's going to be received and then processed. So this is why we see the little porous holes in the cribriform plate. I thought that was kind of interesting. We also have the sella turcica. So sella turcica means Turkish saddle. That's how you translate that. And if that helps you kind of identify it, it kind of looks like a horse's saddle. So this is the saddle of the skull. And so what is housed here? Does anyone remember?
Pituitary gland.
The pituitary gland, exactly. So you can see this little indentation where the pituitary gland will sit. And if this is kind of not making the most sense, then what I would recommend is that you hop into complete anatomy after the lab at some point this week and kind of combine what you know from lab 2 and lab 3 and really put the brain in the skull, take out some pieces, look at where everything's situated, and that might help you put a few pieces together. So yeah, we have the pituitary gland situated in this sella turcica, which is part of the sphenoid bone. And we know that the sphenoid bone shows itself from different angles. So it's really interesting to see it from this internal angle as well as the external and the frontal angle. I'll see it a few more times. So. And then we lastly, right here, we have the internal acoustic meatus. So the internal acoustic meatus, we just talked about what a meatus is. It's going to be a hole, a foramen, right? And the internal acoustic meatus is actually, yes, if you're going to ask this question, it is connected to the external acoustic meatus in a way. So if you're someone like me who does this bad thing where you stick Q-tips up your ears, I know I shouldn't do it, then you're putting the Q-tip in your internal or your external acoustic meatus, right? And that's where that sound is being first received. It's going to pass through into your middle ear. The middle ear is going to be the connection between the external and the internal, if that helps you kind of put pieces together. We don't need to know anything about the ear for this class, but if that helps you just kind of understand how these things are related, then that's there for you. So the internal acoustic meatus we can only see from if we look at the skull from this view. So we won't be able to see it from the external angle, obviously. And then lastly, we have the foramen magnum. So foramen magnum, I think, is very appropriately named. It is a large hole. It is the large passageway for our spinal cord. So our spinal cord will pass through from where the brain is attached. And we know that the last connection is going to be the medulla oblongata. And then from there, it's going to pass down into our vertebrae. Are there any questions on the major structures of the cranial cavity? Nope. All right. If you have a question that you kind of think of afterward, just holla at me. Okay, so we're going to talk a little bit about the cranial foramina. So the cranial foramina, I think, are really interesting because, again, they combine a lot of the knowledge that we learned in lab 2 with lab 3. And there are actually more than 20 cranial foramina that are located all around our skull. And this would make sense, right? Because we know that we have 12 pairs of cranial nerves. So that means we have technically 24 cranial nerves emerging out of everywhere. And some cranial nerves have more than one branching. So there are going to be a lot of different foramina for our cranial nerves to pass through. And why do they have to pass through? Well, because, I mean, you can really see from this image, the skull is creating this shield, right? It really helmets the brain. And so we need little passageways to allow these cranial nerves to get to the muscles that overlie on top of the skull, or sometimes, for example, with the olfactory nerve to get to the different openings that it'll receive sensations from. So we in this class only have to know 5 cranial nerves. We're kind of lucky we don't have to know all 20. And these are the 5 that we need to know. So we have the supraorbital foramen, which is going to be located right above our orbit. And then we have our infraorbital foramen, which is located right under our orbit. So these are, again, appropriately named, and if you know the word parts, you can really understand where they're located or even what their function is. This one doesn't give us the function, obviously, but does anyone know what their function is?
Are they for the trigeminal nerves?
Yeah, they are, exactly. They are exits for the trigeminal nerve. And Emma, I'm gonna put you on the spot one more time. Do you know why they, like what about the trigeminal nerve is really important? For the
It's
location,
oh, they are the the facial movement.
almost, very close. Are they facial movement for trigeminal?
Mm, trigeminal was 5.
Mhm.
Yeah.
Yeah, okay. Do you
Okay.
wanna, does anyone have a different opinion? Different thought?
Isn't it for chewing muscles?
Chewing muscles are gonna be part of it, yep. That's one. So that's like the movement of mastication, but there's one other function that the trigeminal does that we talked a lot about last week.
Is it sensory from the facial, oral, nasal cavities?
Yes, exactly, Sophia. So Emma, you were almost there, right? So it is related to the facial muscles, but it's sensation. So again, this is gonna be really important because you need those innervations of those nerves to be on these specific locations to actually feel anything happening. So if you touch your cheek, right, that part of where your body is receiving that information is probably going to be from that trigeminal nerve that exits right here, the infraorbital foramen. Now, if you touch up here on your forehead, well, you're receiving that sensation that you're touching your forehead from the trigeminal nerve that emerges from the supraorbital foramen. So you can see how the location actually affects what part of the body it's receiving information from. It's really closely related. And exactly like Sophia said, when we talk about the mental foramen, it's a little differently named. It's the mental foramen because it's related to our jaw. And so this is going to be for the trigeminal nerve, but it's also going to be for, again, sensation of this part of our jaw. So they're going to be the sensation that each part of these emergence of the nerves are going to be receiving is directly related to the location. So you can kind of almost block off. Again, there's no direct lines of which part, if the infraorbital is receiving information right here, if it's the supraorbital emergence receiving information here, they're kind of, blurred lines, but you can generally block off that the supraorbital foramen emergence of the trigeminal nerve is going to receive information here. And then we have infraorbital, which is going to receive, under with the cheeks, and then we have our mental. Does that make sense? Yeah, okay, great. So you can see how these labs are really coming together, and we're seeing the connections between the bone, how it's protecting, and then our nervous system where it's communicating. We also have the optic canal, which is going to be found deep in our optic. So it's going to be the small hole that you see. And does anyone know what cranial nerve will emerge from here?
Isn't the optic nerve?
Yeah, wow. That seems pretty intuitive, so great job. It is going to be the optic nerve. And so who said that? What is the optic nerve used for? I don't know who said it.
I said it. And the optic nerve is just the nerve that brings in the information from the retina to the occipital lobe. Yeah.
So the optic nerve is going to be motion of receiving the visual information for our eye. Yeah, exactly. And then we have the superior orbital fissure. So what is going to emerge from here? What is this important for?
Those are for the cranial nerves that control the extrinsic eye movements.
That control the what?
Extrinsic eye movements.
Yeah,
the
eye movements, exactly. The eye movement, eye muscles, and then we also have some nerves and vessels related to glands. So this is from, the structure of it, you can kind of tell it's a bigger fissure, it's a bigger opening, so there are going to be more passageways. We don't need to know any specific details about it, but these are going to be the two important fissures and canals that you need to know that are inside the optic. All right. Does anyone have any questions on any of these foramina? And then I think Annie. Yep. Thanks, Annie. Yep. So it's really important to kind of know what different parts of the words mean, and they can be really helpful. So. Alrighty. One last thing I want to note about the supraorbital foramen, if you're looking for it on any diagrams or if you're looking at it in complete anatomy, it is going to be super, super tiny. So just make sure you don't miss it. It is really, really small compared to the other two. Okay. Alrighty, so quickly on the oral cavity, we're going to talk a lot more about the oral cavity when we talk about digestion. So this will be kind of just a brief overview for you to understand the bones that are related to the oral cavity. We only have two that we really need to know. If you want to think about the oral cavity as also including the mandible, then that would definitely be part of what you're doing here in the oral cavity. So if we're looking at the inferior view though, so from bottom up, I put a camera down below and I was looking at my upper row of teeth, and we'd see the maxillary bone is going to create this palate where our upper teeth are going to sit. And then we also have our palatine bone, which is going to be further back into our oral cavity. Okay. That's not too bad. And then we'll do a quick review of the nasal cavity as well. Again, like I said, this is going to come up again when we talk about lab 7 and 8. But it is a really good idea to just kind of see this information once and be looking at it for the structures. And then when we talk about it again in lab 7 and 8, we'll be talking more about the pathways that respiration follows and digestion follows and how these two cavities are really involved in that. So with the nasal cavity, of course, we have our nasal cartilage. So a lot of bone pictures that we see kind of just looks like a weird opening and you don't see the nose, and that's because it's cartilage, right? So it's not part of bone. But here they drew it just so you can kind of see that the nasal cartilage is going to be the first entrance. And I won't talk too much about the pathway of the air right now, but you can see that it's there. It's the most anterior portion. Then the next part of the bone that we have, so we see the nasal bone up here. It's kind of tiny. It's poorly colored in relation to the maxillary bone, but the nasal cavity has its boundaries right here. That's going to be the bridge of your nose, that upper bridge of your nose. You also have your maxillary, and you can see really from these last two pictures how encompassing the maxillary bone is. It forms the palate of the mouth. It forms quite a large portion of the nasal cavity as well. And we can also see it a little bit if we looked at it from the frontal view, if we were looking at the jaw and the cheekbones. So, so this is the maxillary bone. The next bone that would be really important for the nasal cavity is the ethmoid. And the ethmoid, again, we can see it from a different view when we look at the optic, but we also see it really prominently here in the nasal cavity. So in the nasal cavity, we have these things called nasal conchae. All right, and again, like I said, we're not going to talk about too much detail, but it is important to know that these nasal conchae exist to create more surface area for mucus to warm and humidify the air that passes through. So they're really these little tiny spirals that allow for the air to twist and turn and get humidified and warmed in your nasal cavity. And we have three of them. We have the superior, the middle, and the inferior nasal conchae. And again, they are part of the ethmoid bone. So these will be just the ethmoid, but we have something else that ranges throughout a few different bones, and that's our paranasal sinuses. So you can see our paranasal sinuses as part of the frontal bone. This is the frontal right here. We have some paranasal sinuses in our ethmoid bone. And lastly, we have some in our sphenoid. And the paranasal sinuses are really important. Does anyone know why, what their function is? I think they have a really neat function. Anyone? Does anyone have a guess? So we know when we get sick, we know a lot about our sinuses, right? Because they feel really heavy and we're just kind of congested and we don't feel well. So what happens when your sinuses are normal? What does that mean? So the sinuses are actually there to lighten our brain, right? So they're just these pockets of air. And normally when we're feeling all fine and well, they will be there to lighten the load and the weight that our brain carries, our skull and our brain. But when we're sick, we know that our nasal cavity being very closely connected, these paranasal sinuses will get filled with this infected mucus, and that makes us feel really heavy and brought down. And you can really feel that when you're sick. So these are a very interesting structure when they are working properly. All right, and then the last bone that we have in the nasal cavity is going to be the pterygoid process. I always have a really hard time pronouncing that, but pterygoid process, and it's part of the sphenoid bone. So here again, you can see sphenoid at this point has now branched. It's also the nasal, paranasal sinuses, as well as the pterygoid process. And the pterygoid process is going to be the inferior boundary of our nasal cavity. Any questions on any of these last few slides I've gone over?
Hey, Zara.
Yes.
Can you point out the nasal septum? Because I
Yeah.
don't think like
I was
the
actually
figure-
just going to do that. Yeah.
Yeah.
So we can actually not see the nasal septum from this view. And does anyone know what plane the nasal septum lies on?
Is it the mid-sagittal?
The mid-sagittal, exactly, Emma. So it's not just sagittal, it's actually exactly mid-sagittal, not exactly, but pretty much right in the middle of our body. So you can see the nasal septum right here. So here's the nasal bone and that septum that runs through. And if you, so I had a deviated septum actually when I was born, and I lived with it for several years. And so my septum was not straight. It did not create a line down the middle. And so my cavities were therefore not even. So I had one really large nasal cavity and one really small one where I did most of my breathing in my left nasal cavity and no breathing in my right. Recently I got it fixed, so now I breathe through both of my cavities, so that's kind of neat. But yeah, so the nasal septum is really, really important to make sure that you're breathing evenly through both cavities. Thanks for that, Annie. Anything else? Any other questions? I'm gonna actually pause here and see if I can pull up. I was trying to pull up complete anatomy and it wasn't working earlier. I want to show you all some cool features that complete anatomy has right now, or not has right now, has always. That'll be really helpful for now though. Let's see if I can do this. So by a show of hands, I guess, I can't see everyone, but okay, there we go. By show of hands, how is complete anatomy going for people? Is it useful? Is it kind of difficult to use? Okay, seeing a range, I'm seeing some here, some here. Okay, so is it mostly, usability, or is it just clunky? Like what's going on? How can I better help you to use it? Any feedback? Or would like a quick tutorial walkthrough of how to use it work, help?
I think maybe you may want to point us or direct us toward like useful videos that we might watch, because
Yep.
I know they have videos there. Sometimes I just have to kind of type in, but not always get on the right one. So
Okay, so you're talking about the videos. I actually don't know too much about the videos. I haven't used them before. Annie, do you know anything about the videos for complete anatomy? No.
My complete anatomy doesn't even work, so
Oh.
I feel while I'm struggling.
Oh no. Okay, so when you talk about videos, Didi, what are you referring to?
I don't know exactly. Like, I know for me, like, I don't get anything. Like, I read the first time, like the lab, I don't understand anything. And when I watch the videos, like, I remember watching something about, I think it was the lab too.
Mhm.
It was much clearer. And after watching that, I was able to come back to the lab and was able to explain all of that to myself.
Oh,
So,
great. Okay. So there are videos that I was not aware of that are on complete anatomy that you're finding helpful. So maybe what I can do is, and you said that these are videos that we made. These are not videos that came with complete
I think those are videos that like they came with the like the it
Oh, so
wasn't made by us yet, but
Okay.
they're
Okay.
useful.
All right. Maybe what I can do is see if I can find these videos, and I think I know what you're talking about. I've never actually used them, but maybe I can look at some and see if they are if there are some helpful ones for us. Thank you for that. And then I also saw that Presley said it's hard to make your own screens without those given by the TA. that's to be expected, right? Complete anatomy number 1 is very slow and crashes all the time, and so that can be frustrating for sure. But the more that you try to make your own screens or even just try to look things up, then the easier it'll get. When I was a student, I also did not really like using complete anatomy, which I think was something that I missed out on a little bit, and I really realized the importance and just everything that complete anatomy has to offer when I became a student, especially in COVID times where we don't have models in front of us, right? So this is not only the next best thing, but this is just as good as having a model in front of you because of how you can rotate it. It's 3D. You can click on different objects to see what those structures actually are and more details about it. So the more you use it, you will get more comfortable with it, I promise. For now, I know it feels a little clunky and weird, but every now and then, if you can just look up a few things and get a little comfortable, it will definitely help. So, okay, so yes, Nicole.
I use Complete Anatomy on my iPad, which has worked like really well. So
Okay.
I don't know, like obviously not everyone has an iPad, but maybe even the app on the iPhone, it might not be big, but it's so much more responsive and like never crashes.
Oh, perfect. Well, that's good. That's really good to know. So if you have an iOS device and you want to see if you can download the app, then that would be a great idea as well. Okay, cool. So I think that also when you're on a Zoom call, it just is not the greatest. So mine is not loading right now, but I do want to show you a feature as we are talking. So we really did talk a lot about these different parts of the bones that are important, right? Like the cribriform plate, the sella turcica, the pterygoid process. So these are structures on identifiable bones that we can point out on these bone boundaries, right? We know we have 216 bones. If we take out those, if we separate those 216 bones, there's different parts on it that we can identify. So one way that you can study these different parts that we are asking you to know is that, can everyone see my complete anatomy screen? Let's go. Yeah. Okay, so one way that we can identify these is if we click on, so let's see, this is the sphenoid. It's really slow. Okay, can everyone see that it says that this is a sphenoid bone? Yep, okay. So right here, you can see that there's information. We can see, you know, a lot more stuff than we actually need to know for this class. If you are interested, there's tons of information over here. But the useful part is that this little button, parts, that will be the useful button for you all, because you can click this and then actually see different parts that we have been talking about. So Dr. Johnson really wanted me to make sure that you all were aware that you can use this feature to then identify different things. Right here we can see the pterygoid process. And then if we click it, it'll actually help us identify it, I believe. So there we go, we can see which is the pterygoid process. I don't really love this image, but you get the point of what I'm saying, that you can use complete anatomy to identify things, even if you don't want to type them in necessarily. You can start with the sphenoid bone and then kind of break down the different parts that you would need to know. These are going to have way more, it's going to have way more information than you actually need to know, so don't let it overwhelm you. Just if this is useful to you, then use it. Go ahead and stop that. And so 1 second. Okay, I think that we have one more slide for the cranial. Oh, we don't. Okay, so then I'm just going to share my screen really quickly for the optic canal, the orbit, sorry. So with the orbit, we have 6 important bones. And again, like I said, these bones are showing up all over the place from all different angles. That's the really cool part about the skull, is that they're all really connected. And there's different parts that are important for different functions. So here again, we see the sphenoid bone showing up all over the place. And it is creating the posterior boundary of our orbit. We have the zygomatic, the maxillary, and the frontal, which will create this anterior boundary of our orbit, and those are going to be those bones that you kind of get hit if you got punched in the eye. These might be some bones that were injured. And then we also have our lacrimal and our ethmoid. Just remember that the lacrimal and the ethmoid, they look so similar, so remember that the lacrimal comes before the ethmoid. For me, I think of lacrimal coming before the ethmoid because of tears, right? So we cry right here on the anterior side of our face, so the tears are going to be in front of the ethmoid bone. Alrighty, and then again, we can see here the optic canal and then the superior fissure. Any questions on this before we jump into some poll everywhere? Alrighty, so we're gonna do a few poll everywhere questions. These are gonna be those external bones I was talking about. Hopefully these are super quick and easy. Again, they line up really well with the lobes that we have as well. Our brain lobes. Okay, so 30 seconds, make sure you get your response in. Alrighty, and we have 27, perfect. So these are gonna be a very typical question that you should expect on a quiz. There's probably gonna be a good amount of identifications of different parts of the skull. So this one is obviously the temporal bone. The temporal bone lines up exactly with the temporal lobe, which we know again is in this region of the brain as well. And we can see the boundaries that are formed for the temporal lobe. So a few people were parietal and occipital. So keep in mind where these two, note that you were not able to identify the temporal and maybe where the parietal and the occipital actually are. Okay. Alrighty, so here's one more. Okay, so we have everyone's answers in, and let's see how we did. So this is going to be the parietal bone. Again, parietal bone is going to line up exactly with the parietal lobe, just like we saw with the temporal. Okay, so a few of us said occipital. Again, keep in mind where the occipital is going to be. I'm not going to point it out yet because we're probably going to have a question, I can't remember, on it. So just keep in mind the mistakes that you're making right now and just trying to make sure that you are identifying why you're making those mistakes. Okay, 28. Let's see how we did. Okay, awesome. So we already looked this one up actually on complete anatomy, so I'm really glad to see that everyone's paying attention. That was the sphenoid bone exactly. The sphenoid bone again is really interesting because you can see it from several different angles. You can see it in the optic. You can also see it if we were looking into the nasal cavity as well. Okay, on a roll. And lastly, which of these is the zygomatic? Oh, I didn't put a timer. Just waiting on 3 more people. right. So which of these is a zygomatic? Let's see. So we know that the zygomatic is going to be this bone that forms our cheek, and it's going to actually form the boundary between what bone right here? Does anyone know what this bone is? You can see my mouse, right?
The maxillary.
Maxillary, exactly. Thank you, Caitlin. And which bone is this? Little hard to see because it's very tiny.
Is it the ethmoid?
It is the ethmoid. Yep, exactly. So my mouse right now is on the ethmoid, and then if I move it right here, what is that bone?
Lacrimal.
Thank you, Nicole. That is the lacrimal, exactly. What is this bone?
Frontal?
Frontal. And what is this right here? Little tiny indentation.
Supraorbital foramen?
Thank you, yeah. Is this Matt? I can't see.
Yes, it is.
Matt, yeah, thank you, Matt. Awesome. Okay, and then what is this bone right here? Right here.
Is it the sphenoid again?
That is the sphenoid, yep. Perfect. So we can really see that it's very important to make sure that you can identify these bones from several different angles. So we saw the sphenoid from a different angle. This is still the sphenoid. It's just we're seeing it from inside the orbit, so it looks a little bit different. Any questions on these poll everywhere questions or anything about the skull? I know there is a lot of information for the skull, and that's kind of where the bulk of lab 3 seems to come from. Like I said, again, what I would really recommend you do is break these into the different sections that we talked about. Each of these groupings of bones are serving a specific function, whether it's the nasal cavity, whether it's the orbit, whether it's the oral cavity, whether it's housing the, literally holding in the brain. So if you identify these functions and really group them in that way, it will be more helpful to identify the different structures. Annie, do you have any other suggestions for this unit? Nope. Okay. All right, so with that, we're going to jump right into case 1. This one should not take you too long, so I'm going to give you about 10 minutes. We're going to be in the same groups as last time, which I should have written down. That would have been helpful. Okay, so what we'll have to do, how did I do this? Yeah, that's not written down. Okay, we're gonna have to do this manually. So let's see. Alrighty, can you raise your hand if you were in breakout room 1? If you remember being in breakout room 1. No, we're not gonna do it that way. Can you raise your hand if you were with Andy Chen? Was anyone with Andy? No one was with Andy. Was Andy there last week? Yeah, who was with Andy? Ashley, okay. FA, okay. Ashley, FA, who else?
I think I was too.
Who was that? Nicholas. Okay.
Nicholas. Yeah.
Thank you. Okay, let's do that. Andy, Ashley, FA, Nicholas. Okay. Who was with Dominic? Who's raising their hand?
I think
Julia, Logan, okay, and then Kyle, who else? If I'm missing you, just shout your name. Julia, Logan, Nicholas. Anyone else was with you all?
I'm looking at the worksheet from last time, and it says Matthew was in our group too.
Who?
Yeah, it's me.
Yeah.
Sorry, who is that?
That worksheet. It's me.
Matt?
Yes.
Okay. Alrighty. Who's next? Brandon W.
Nicole.
Nicole, Emma, Nivi. Okay, thank you.
Sydney was in there too.
Nicole, Sydney, Nivi, Brandon, and then who else? one more person, right? Or is that it? So I have Nicole, Brandon, Nibby, and Sydney. Sound good? Okay. Who is with?
Wait, did you say my name too?
Oh, and Emma. I was like, there was someone else. Thank you. Thank you. All right. Who is with Sydney? We have Sydney. Who is with Sophia? Presley, Katie, Millie. Presley, Katie, Millie. Okay.
And gospel.
And gospel. Okay. Thank you. All right. And then who else do we have? Who's with Lauren?
Gretchen.
Julia, Gretchen, Lauren. Who else?
Julia.
Allison. Okay. So Julia, Grant, Gretchen, Lauren, Allison. Okay.
And me.
And Brandon. Okay. And Dee Dee, which group were you in?
I don't
Brandon,
remember. The only person I remember is Catalina.
Is
Yeah, you were in my group.
okay, so this is the last group probably. Okay, so Caitlin, Dee Dee, Emily, was that right? Were you in that group? Okay, and then Faith, were you in that group? Sorry, I can't see Faith. Where are you?
Mm-hmm.
Yeah, you were in that group?
Faith and Josh.
Faith and Josh. Perfect. We got it. Yay. Okay. That is everyone. I will go ahead and open those. Thank you so much for your patience, everyone, on that. So like I said, 10 minutes shouldn't be too bad. Try to do your best without looking at the lab text to recall and really think through these questions. And then if you have any questions, we'll definitely review it. So let me go ahead and open these breakout rooms. I will see you all soon. The recording, then I will share my screen. Okay, all set. Annie's back. We missed you. Okay, let's see how we did here. So which of these landmarks on the thoracic vertebrae is the lamina? So we just talked about how the lamina is the arch that connects the spinous process. So then B is going to be the correct answer. It seems like we had a little bit of a few different answers here. So okay, good. So this is a great example of how you can confuse these two attachments. So what is D actually labeling?
It's the pedicle.
Pedicles, exactly. So not peduncles, not the lamina, but the pedicle. And then B is going to be our lamina. So you can see how just by these two pictures, this one looks so clear, right? We can see that arch that connects the spinous process to the articular process. And then we go to this picture that's more anatomically representative and it just doesn't look right. So this is a really good example of why complete anatomy would be a great study source for you all. Okay. Next question. I better get 100 on this one. I'm missing a few people, 3 people, 2. I'll give you a little bit of time. All right, there we go. Okay, so which of these is the pedicle? Let's see. Ooh, hoping to see 100. Dang it. Okay, so we did talk about how this is going to be the pedicle, right? D is going to be our pedicle. E is going to be, anyone know? I might give away the next one. What is E going to be?
Vertebral foramen.
So this is actually not, who said that? Caitlin? Okay. So this is actually not going to be the vertebral foramen. Do you have a different idea? So Caitlin, what is the vertebral foramen? What do we know it as?
It's the location of the spinal cord.
Spinal cord, exactly. Okay. So we know that the spinal cord location has to actually be an opening, right? So this is going to be this is going to be the vertebral foramen. But what do you think this one is?
Is it the articular process?
So not the articular process. And I think this image is a little tricky, right? Because we're looking at it directly from the top. Let me just scroll right back here for a second. So what we were looking at when I was referring to E is actually this part and also this part. So what would that be?
The body.
The body, exactly, yeah. So good example of why angle is really important to help you understand what you're looking at. Okay. Let's do this one. Set a timer. Okay, I'm missing 3 other people. I'm not going to set a timer, but 3 people. Go ahead and put your response in. All right. And let's see how we did. Okay, so spinous process, most of us said A, and that is exactly right. A is going to be the correct answer. And C, I'm going to make sure I don't give this off. Okay, so which one, what is C? What would you label C as? Anyone I have not heard from today? And Andy looks like he's ready. He's got it. No? Was that not it? You didn't have the answer?
Is it the transverse process?
It is the transverse process. Thank you so much. Okay, any questions on this general terminology? Oh, we have one more actually.
What's the difference between the spinous process and the transverse process?
Great question. So the spinous process is going to run along our spine, right? And it's actually, if you feel on your vertebrae, it's the one that you can palpate. So it's that process, that protrusion that you can palpate all the way down your spine when you see those little circles, right? That's your spinous process. Your transverse process is actually going to go more to the lateral, to your laterals, to your sides, right? And we know that it's actually really important for articulations. Does anyone know what they are important for articulations for? What they are important articulations for, I'm sorry. What structure? Remember when we say articulations, they're fancy word for like a connection, a joining. Does this help?
Wait, are we talking about our spinous or articulating?
We're talking about what the transverse process articulates to.
Oh, just kidding. Okay.
Is it the ribs?
It is the ribs. Yeah, it's the ribs. Exactly. So go ahead and try this question, and then we'll talk a little bit more about it.
Wait, I have one question about all of these. Do they also all connect to muscles?
They most definitely do, yes. And we will talk more about muscles when we get there. But yeah, that was a great question. They do definitely connect to muscles as well.
Thank you.
Right, just a quick question. Where is E in this picture?
Where is the picture?
The one on the question. We have 5
Oh,
choices.
Can you not see anything?
I can see the picture, I can see the question, but 5 choices, 4 labels.
Oh, so you cannot see the spinal, like the vertebrae?
No, he's saying like we see labels A, B, C, D, but there's answer choices for A, B, C, D, E.
Yeah,
So
ignore it. Ignore E. Thank you. Okay, one more person. Thank you. Okay, so which of these landmarks does not form an articulation or a joint for the ribs? Okay, so what are we thinking here? Anyone have a thought process before I show us the right answer? Anyone want to defend their answer? Who picked E? Y'all are not paying attention. It's okay. We're trying to get through this quickly, right? It is too late in the semester already. Okay. Can someone defend their answer for me? Which of these is not an articulation for the rib?
I could defend my answer, which
Okay,
is
thank you, Emma.
answer B, because I kind of remember that the rib, it articulates at 2 points, and point A is also going to be touching the bottom of the top rib, which is going to be sandwiched between the two spinal chunk things.
Okay, yeah.
So, yeah.
Okay, so you are saying that B is not an articulation for the ribs, is that correct?
Yeah,
Okay.
because A and D and C are, yeah.
A and B and C, okay, thank you. Anyone else want to try to defend their answer? Maybe someone who wrote something other than B?
I put C.
Okay.
Because in the lab text there was that thing about the costal facets, and the facets were where the articulations were, and C isn't in one of those spots.
And C is not in one of the costal facets. Okay, great. So we have two quite differing opinions right now. We have B and C. So let's look into this a little bit more. So when we're looking at C, this is not a great image, number one, but C is actually on what structure, what larger structure of the vertebrae? We know all of these are facets, so what is this facet on? What structure?
Spinous process.
Not the spinous process.
It's on the laminae.
Which one?
Isn't it on the laminae, the arch?
It is not on the laminae. Nope.
Oh.
The transverse process?
It is not on the transverse process. We're getting close though. We've eliminated quite a few. What's left?
The pedicle?
Not the pedicle.
And it's the body. That's the only one left.
Not the body.
What? Oh, the articulate processes.
The articular processes, exactly. Okay. Yeah, so we were getting there. We were rolling right through these general characteristics, but it is actually the articular process. So I'm going to try to pull up a complete anatomy screen so I can show this a little better, because I think this one deserves a little bit of our time. All right. Let me, can you all see complete anatomy? We have a few questions. Okay, can you all see my complete anatomy screen? Yeah, okay. All right, so we're gonna look, I did not make a screen yet, but I'm just gonna go ahead and take out a few things while we're talking so that I can show you all the vertebrae. So I wanna focus in on these thoracic vertebrae. We know that some of the characteristics of the thoracic vertebrae, they have these sloping spinous processes, and they have articulations with the ribs, right? So we can see all of these are going to be thoracic vertebrae. So I'm going to scroll into one of them. Okay, let me get it nice and perfect angle. Let's see. All right, that'll do. And then I'm going to get rid of a few of these ribs. Hopefully you all can see while I'm doing this what can be helpful when you're using complete anatomy. Okay. And of course it's very slow because of Zoom, so bear with me for 1 second. All right, so now I have isolated this one rib right here, and I don't actually know which rib this is. Let me see. So slow, it's painfully slow. Okay, so this is the fourth rib. We're looking at the fourth rib, perfect. So I'm gonna zoom in here on the fourth rib and its articulation to the vertebrae. Okay, there we go. So right here from this angle, automatically what I can see is that this vertebrae right here, which is going to be which vertebrae? The answer is given off on the screen. This is going to be the third thoracic vertebrae. Okay, so it's going to be a thoracic vertebrae was what I was looking for. And here we have another thoracic vertebrae, and we have this fourth rib. So what you can see automatically right off the bat is that there's an articulation, so a joint between the rib below, so the vertebrae below, so vertebrae 4, and the vertebrae above. And this is what we call those articular processes. So you can see how they sandwich like this. This is how I like to think of them, as like two hands sandwiched like this, all along the spinal cord. And they're pretty flat and large facets compared to the costal facets, which we can see right here. So you can see that this is a costal facet that we were looking at. This was C on the picture. This was B, or no, this was A, I believe, and then this was B if it was down here. So here you can really see how the ribs are attaching to these vertebrae. So exactly like Emma was saying, we know that the facets from the vertebrae above and the vertebrae below are going to form a little spoon to hold the rib, and they're going to hold the head of the rib. So if we were to add rib 3 back in here, we would see that it would fit right into this little pocket. It would attach to this costal facet of the second thoracic vertebrae, this costal facet of the third thoracic vertebrae, and this would be where the head would sit. Now, in addition to the head, the rib also has this facet on its tubercle. Okay, so we can see this facet right here, and again, it's separated by the neck of the rib, right? And here's this tubercle. So we can see that this is where it attaches to the transverse processes facet. So if I were to add back rib 3, like I said, it would attach. It would attach from here where the head was, here where the tubercle was, and then it would wrap around, and that would be where our rib attached. So this is the transverse process, and we can see how it's attached. This facet is on the transverse process. This one again, these two were A and B, and this facet right here on the articular process is not part of the rib attachments. I went really slowly on that, and hopefully that makes it a little clearer about these connections between the ribs. Sorry for all this rotation. 1 second. One more thing I want you to notice is how ribs will attach. So this is rib 4. It's attaching between 3 and 4, and it is sloping a little bit downward because it attaches to 3 on the head, but on the tubercle it is only attached to 4. So it creates a little bit of a slope, right? And we know that the ribs, they're not going to just be straight on the transverse plane. They kind of slope down a little bit. Does this help a little bit clear up the facets? Yeah. So this is going to be a really important concept. So I hope that me demonstrating how to use complete anatomy a little bit to understand this as well was a little bit helpful. I believe you can even click, yep, you can even click exactly on the facet and they will tell you which facet it is. And you can do a little bit of practice to make sure you're aligning the facets correctly. If we were in person, I would say take a rib and see if you can attach it to the spinal cord. But honestly, this is just as good as long as you take some time and just scroll through it. Move it around, make sure you're understanding the different articulations. Okay, hopefully that was helpful. All right, any questions now on that question? Doing good? Okay, let's move right along. I think we're jumping right into case 2 actually, which is our last case for today. Yep, we're jumping into case 2. We'll give you a little bit more time on this case. What time is it? So we'll meet up at 7:15. How about that? And just quickly go over it, and then we'll be done for lab today. This case is a little bit longer, and I again prefer that you take some time to answer some questions that are more recall as much as you can from your memory before you look into the lab text. That will be the most beneficial for you. Really talk to each other. I'm seeing that there is really great communication when I am jumping into these groups, so make sure you're keeping that up. If you have that one rogue, strange idea, voice it, because it might be the right answer, right? So, talk to each other, make sure you're including everyone's ideas, and see how far you can get on this case. All right, I will open up the breakout rooms. Okay, so 7:15, I'll stop by everyone's rooms and make sure everyone's doing well, but use the help button if you need me. Plenty of time for you all to go through these 7 questions. There is a lot that we can talk about for these questions, so I'm going to start off by first answering Nicole's question that we had earlier about the rib articulation. So Annie and I believe that we can confidently say that the ribs do not articulate at the xiphoid process. So the rib cartilage, the cartilage that attaches 7 through 10, it will articulate right above the xiphoid process. I think for our purposes, we can say that there is no rib that articulates at the xiphoid process. So it is really vulnerable, right? It's not attached to anything. It's just a little dangly piece on the sternum. So hopefully that answered your question. I also had a few really great questions throughout these case studies, and I really appreciate you asking questions that gets even me trying to think about what could be the right answer. So we'll start off with question 3. I hope that question 1 was okay. Oh, actually, we'll do question 2 first. We'll do question 2 first. Can you all see my screen now? Can you see it? Yeah. Yes. Andy, can you see my screen? Anyone? Okay, great. Thank you. All right, so let's talk about question 2 really quickly. Can anyone explain to me what they think the significance of the growth of the odontoid process is in this patient? What did you all think as a group was the significance of the odontoid process? Preferably someone I haven't heard from today, and I know we're feeling a little quiet, but the faster we can get through this, the faster we'll be done. Anyone?
Our group put that it would potentially affect the rotation, the C1 and the C2 vertebrae, just because its primary focus right there is for rotation.
Yep, exactly, absolutely. So you hit the nail on the head, right? We say rotation for the axis, and this is going to be really important because if we cannot rotate our head, and hopefully many of us have been in a car or maybe even drive cars, and you know that you have to be able to look left and right sometimes. And if you cannot, because you have some kind of growth that impedes the odontoid process's function, then you might not be able to look left and right. We can maybe even interpret that this might have something to do with the car accident, why it happened, right? So that's kind of an interesting way to look at this question, is that the odontoid process really impacted this patient's ability to look left and right, which then in turn might have caused a pretty dangerous accident. Okay, and what do we call the joint between the C1 and C2? Anyone remember? It's named pretty appropriately. I'm not going to cold call because I hate when that happens. Anyone else want to try? You can just even guess what it could be, just based on what you know the C1 and C2 are named.
The atlas axis joint?
That sounds okay. Yeah, the atlas axis joint. Very, very close, Sophia. It's called the atlantoaxial joint. Yeah, thank you for that. So that's going to be the joint between C1 and C2. How about, does anyone know the joint between the occipital bone, between the occipital bone and the atlas?
The atlanto-occipital.
Yeah, the atlanto-occipital. Thank you so much, Presley. Exactly right. And I want you to think about joints a little bit, and especially like joints that have names like this. We talked a little bit about the joints and the ribs, but joints are going to come up a lot next week, and so it's really important to start thinking about joints and what they connect. Joints are usually appropriately named, like most other things in anatomy. Some things, of course, are not the most straightforward. But really breaking down these parts helps you understand. Atlanto-occipital does not seem that daunting when you know that that means it connects the atlas to the occipital bone. Okay, great. So we'll talk a little bit about question 3. And I know there are a few people who got there, so I'm going to ask for a volunteer if anyone would like to try to explain why this patient's injuries may explain his unresponsiveness. Anyone want to give this a shot?
Our group said that there was an injury to the passageway for the vertebral artery, which would cause lack of blood flow to the brain, which would cause then unconsciousness. Yeah, exactly right. Yeah, so we're gonna, when we're talking about unconsciousness, unresponsiveness, we're not talking about something usually, right, life-threatening. Hopefully, as long as we can fix whatever is blocking the blood flow, then we can bring back consciousness and responsiveness. I know a few groups were thinking more along the lines of spinal cord may be injured or the medulla oblongata may be injured. And those are more, you know, I'm using this term very loosely, serious structures, right? Because if you were to injure the spinal cord or the medulla oblongata, they will have much more fatal consequences other than just unresponsiveness. So I want to quickly pull up this picture right here. Can you all see my screen? Google Images. Can you see Google Images? Yeah, perfect. Okay. Like I said, Google Images is sometimes really helpful to kind of just understand things from a different lens, because a lot of times anatomy is drawn in different ways, so that can sometimes be helpful to kind of see things in different ways. I'll always prefer to complete anatomy though first. But we'll use this image of the atlas. So we were talking about why the patient has unresponsiveness. I'm using the atlas because it's very clear what the structures are. So we have the vertebral foramen, and then we have these transverse foramen. And this is what's really important, because the transverse foramen allows for the passage of these arteries, right, that serve the brain and provide blood to the brain, blood flow to the brain. Without these transverse foramina allowing for this passageway, we wouldn't have a protection for these blood vessels. But if this was to get injured, then we know that we could possibly impinge on these blood vessels, and then therefore cut off the circulation to the brain. So that's exactly what happened. This injury in this transverse process in C1 through C4 damaged this transverse foramen, which then allowed for, didn't allow for the proper function of the blood vessels that will provide blood to the brain. Great, thank you so much. Who responded? I'm so sorry. Gretchen, thank you so much, Gretchen. Okay, next question, we'll do 5 really quickly. Okay, so a patient complains about shooting pain down their leg. You determined that L1 spinal nerve is involved. So hopefully for question 4, you got that it was the body of the lumbar vertebrae. And so what does that mean? Can someone explain to us why this pain may be experienced by this patient? And again, I know there are some groups who got there.
If the body is broken, then it can impact the intervertebral foramen and cut off the nerve, which usually explain the pain.
Yep, exactly right. So the intervertebral foramen is this sort of imaginary, but not really, creation of a hole that exists because 2 vertebrae come together and form this little passageway, right? So vertebrae on the top, vertebrae on the bottom, they form this little passageway. And this is where we know our spinal nerves will exit out of. So what happened here was that the body collapsed. And if the body collapsed, we can assume that there was a little bit more damage alongside some more structures really close to the body, right? So right at the body is that pedicle. That pedicle is going to help form this intervertebral foramen. So it's collapsed, right? Oh, that didn't help. Okay, it's right here. It's collapsed. So now anything inside of our intervertebral foramen has been squished really, squished down. And so that might be causing this impingement on the spinal nerve that will affect her leg in turn. And someone asked a good question, well, what does that have to do with anything with the pain that this person is experiencing? Does it have to do with, like, nerve endings related, pain receptors around there? And we know that pain is a sensation that we experience, and maybe that sensation was locked off. These are all great questions, and I don't exactly know why we said that the pain was being experienced in the leg. From what I understand,
when you're impeding the spinal nerve, maybe even not completely, and Sophia, I was thinking a little bit about this question, maybe if you're not impeding it completely so that the function is completely gone, then you're still receiving some signals, but it's just not going right. Something is just incorrect, right? That's one possibility. Another possibility is that when we see questions like this where it talks about pain, normal functions, I put them in quotations because they're very subjective terms and they don't really give us a ton of information. So it could just have been a poorly worded question to ask about the pain. But if you had something along the lines of the intervertebral foramen was damaged, therefore, impinging or damaging the spinal nerve that exits out of L1, then you would be exactly right. Annie, did you have anything to add to this question about why it's referring to pain? No?
I just kind of thought the answer key made sense in the sense of like it was probably putting pressure on the spinal nerve.
Yeah. Mm-hmm. Yeah. So it's not completely cutting out that information that's being received and sent, but it is creating some kind of irregular function, irregular sensations.
Sorry, wouldn't like putting pressure on the spinal nerve, even if it were to cut it off, like if it destroyed the nerves, wouldn't it be possible for them to be firing action potentials from the spine, but not necessarily from the legs? Does that make sense?
Yeah, that does make sense, right? Because that means that so what you're saying is that any information traveling, any descending information would get there, but just not be able to get to where it would get down to the L1 spinal nerve, but not be able to pass.
Kind of like the sensory information is being generated in the spine, but not the leg, but because it's the spinal nerve for the leg, they think it's for the leg.
That sounds good. I'm actually not sure completely, but if anyone else has anything to add on that, if I saw FA like nodding his head saying, yeah, that sounds good. Does that sound good to everyone else? Yeah, Annie?
I'm not too sure myself.
Yeah, but I'm the first one to admit when I don't know exactly what's going on. So like I've said for a few times today, I will find an answer for you. And I would even maybe appreciate you writing that down so that I can look into that explanation you gave, Emma. But yeah, thank you for that. Thank you for that question, Sophia. These are great questions to kind of get everyone thinking about what is really being asked. So great job. All right. Any other questions on 5, 3, 2, 7? Hopefully was okay. I just want to mention that if you're interested, when these cranial sutures fuse incorrectly or too early, they can lead to these odd facial features that are called cranial synostosis. Sorry. So that was just something that Dr. Johnson wanted me to make sure that you're aware of if you're interested, what can happen if it's dysfunctional. Okay. How are we doing? Lab 3, feeling okay? Yeah? Not too bad. Hopefully the information was a little easier to digest this time. But you are hopefully seeing that it's very interconnected to the last 2 labs we learned. If you're feeling a little bit down, right? We're in week 6. If you're feeling a little, stressed out about the next quiz coming up, if you're feeling fine and dandy and you just want to say hi, stop by office hours. We can chat, figure things out. I am more than willing to go over your quiz as well and kind of even talk through every question that you would like to go through. I really want to do everything I can to help you all succeed in the class, and whatever I can do to benefit you on that, please let me know. Annie will be leading a Kahoot now, and there should also be a review session for this information as we get closer to quiz 2. But please, before then, make sure that you have looked over all the bolded terms in the lab manual. Look into complete anatomy. I want to, before I stop talking, I just want to share my screen on complete anatomy because someone asked a question about the medulla oblongata, and if it's, where does it emerge? Is it connected, does it pass through C1 and C2? And this is another, just a little quick tutorial I want to show on complete anatomy. So I just want to show like how this can be very helpful when you're answering these questions like this. So The question is, does the medulla oblongata pass through C1 and C2, or is it just the spinal cord? Great question. Let's find out. So right now what I've done is I've taken just the skeletal system. So I just have the skeletal system on. You all can see my screen, right? Or can you not? My complete anatomy screen?
No.
No. That would be a good thing to do. Okay, now can you see it?
Yes.
Yeah, okay. So I first started out with just turning on the skeleton system, right? So here's just the skeleton, and then I clicked on the occipital bone, and I took it out. I said hide. Now I can see into the skull. And what I'm going to do is I'm going to search for the medulla oblongata. Whatever loads. Okay, and I'm going to go ahead and add the pyramids of the medulla. I'm going to add both of them just so that we can see it nice and full. Okay, perfect. So now complete anatomy has shown me exactly where the medulla oblongata is in relation to the skeleton. And I can just rotate a little bit, I can zoom in, and now I can say with confidence to whoever asked that question, the medulla does not pass through any of the vertebrae. So you can see right here that this would be the where the spinal cord would begin. But I wanted to show you what I did to figure that out, because this is a helpful tool when you're studying and you're asking yourself, well, does it do this? Is this, right? If you ask these questions to me, I want to show you what I'm doing to figure it out, and I hope that every tutorial I'm showing you on complete anatomy is beneficial. Like I said, please just a few minutes when you're studying, go on complete anatomy, try a few things. It'll get easier with time. But is it helping for me to show you complete anatomy every now and then? Is that helpful, or is that just, that is helpful? Okay. So keep telling me more things that will help you with using complete anatomy. Like I said, it's our only resource for the human body. We don't have models in front of us, but it is sometimes even better than the models. So the more that we get comfortable using it, the better. Okay. That is all I have. Does anyone have any questions for me? If not, I'm going to go ahead and switch over host privileges to, if not, do you already have host?
I'm not sure, but I do still have the share screen option, so that might work fine.
Okay, perfect. Then from now on, Annie is going to take over and lead the Kahoot session. So if you have any questions, just shoot me a text while we're in this group. Oh, there it is, make host. Okay. Yeah, just shoot me a text in the chat. Oh, sorry, Annie, can you make me a co-host so I can join breakout rooms?
How do I do that?
Go to participants.
Okay.
And click on the little more button next to my name.
Oh. Wow, technology. We love it. Okay.
So yeah, so if you have any questions, shoot me a text in the chat and then we'll jump into the breakout room.
Okay.
All right, Annie, all you.
Great. Okay, so I was having some technical issues earlier, but I stole my friend's laptop and audio equipment, so here we are. So, can y'all see the Kahoot?
Annie, I'm so sorry. Before we go any further, I don't see breakout rooms, so we might have to make me host as long as you're able to still share your screen.
Okay. Let's do that.
Okay,
did that work?
Thank you. Yeah, that did. Thank you.
All right. Kahoot.
There you go. I also want to say that you by no means have to stay, but this is going to be a good review for you all if you want to stay.
Yeah, I went through the questions and I think they're pretty good. So it is a good review if you guys are here.
Hope that answered your question, Gospel. Like I said, if anyone needs to head out, you're more than welcome to. We're done with class.
Also, how many people are left? Because I don't know if I can see that. Oh wait, 18. Never mind. Huh. Anyone else? Okay. Okay, well, let's get started. Okay. All right, good job. So right off the bat, we could see that the vertebral body was like a lot bigger than some of the other ones, like the cervical ones that barely have any, and the thoracic ones, which are a little smaller. So that's a good indicator if it's a lumbar vertebrae.
Sorry,
Hi.
I was trying to figure out what to do. Okay, what's up?
Okay, so like one of the questions you asked earlier when I answered spinous process, and then everyone like went around and we like couldn't.
Oh, yeah, all the different terms. Yeah.
Okay, so I'm looking at the picture, or I guess I could have just said it was in the lab text, but this picture of the thoracic vertebra in the lab.
Yeah.
Uh-huh. And in my notes I read that the spinous process was long and downward sloping.
Mm-hmm.
And I just assumed that that was like that thing.
Yeah.
But is that the transverse process? And
No, that's a good question. So do you have the picture that kind of goes along with it? So there's like the the one that's like right next to it, right? Yeah.
Yeah.
So you can see that the downward sloping is going to be the really skinny process in the middle, right? That's the spinous process.
Mm-hmm.
The little like protrusion on the lateral view where you see a tiny fossa. I maybe I should just share my screen. Okay. So you see this little tiny facet right here, and then this little protrusion. So that's actually the articular process. Here's the other articular process. So it's not the transverse process. The transverse process is right here, right? This is the transverse process that you can.
Oh, yeah.
These are the articular processes, and so here you can only see the superior processes, but the inferior are underneath.
Okay.
Does that kind of help with the perspective?
Yeah, so on the right picture,
yeah,
the thing going straight back, that's the spinous process.
This one, yep.
Then the two side ones are the transverse.
Yeah.
And then the little indents are the articular.
This one right here, these indents, they line up with this.
Okay.
So articular processes, the superior and inferior, I think of them as like hands touching like this, and they connect every single vertebrae to each other. So they have to run down the entire cord. No matter which spinal section you're looking at, they're going to have articular processes, and you'll find them on every single vertebrae because they have to attach to each other, right?
Okay.
And they're not going to look very different because they only have that like up and down function. Now the transverse processes and the spinous processes, those, like you said, they look a little different. Like the thoracic one slopes down a little bit versus the cervical one. So those are a little tricky. These are always going to be just like that. And they're going to come right off of the pedicle, if that helps as well. So if I go back to like, let's see. If I go back to this picture, if you see, here's the pedicle, right?
Mm-hmm.
And right attached to the pedicle is going to be the the superior and the inferior articular process.
Mm-hmm.
They're going to be attached right to the pedicle. So here's the pedicle. And we know that the pedicle forms the intervertebral foramen. So the pedicle attaches to these articular processes. The articular process then attaches the transverse process. And I can go back to this image and we can confirm that. Mm-hmm. So the blue, see the transverse process. Does that kind of help?
Wait, yeah, and then I'm sorry. So then, what is that part sticking down then?
Which one? Here?
Yeah.
This is the spinous process. So then this is.
Oh, so it is.
It is the spinous process, yeah.
Okay.
But it's
But
not
that
like
articular process is not on the spinous process. It's just the
Yeah.
ankle.
it just looks like it in this angle.
Okay.
Exactly. It is not on it. I wish I could, well, maybe I can just pull up complete anatomy because it would definitely be helpful to like rotate it. Yeah, it's complete anatomy, come on.
And then
And it works really well on your iPad.
yeah, it does.
Okay, that's good to know. What was your question?
Just sorry, I'm like really at this point, like 3 hours later, and I've been doing this all afternoon, confusing all of the.
No, you're totally fine. What's up?
So then where the causal facet arrow is on the left, that first dot, that's transverse on
This
the
one?
transverse process. Yeah.
This one?
Yeah.
Yeah, this is the transverse process, and this one is the same transverse process.
Yeah. Okay.
Actually, this one corresponds to this one, but yeah.
Yeah.
Let me just show you really quickly complete anatomy. Okay. So if you get a chance, I would just like hop into complete anatomy and pull up an image of the thoracic vertebrae. But here we can see everything I was saying. So the body is right here. Pedicle is this middle portion. Is that too small? The pedicle is this middle portion right here. And then right off of the pedicles, we see the articular processes, right? And so exactly like how that image looks like, it just kind of looks like it's attached, like the spinous process for thoracic is attached, but it's not, right? We know that the articular processes are their own thing. And then if we rotate, we can see that the lamina is what the spinous process is attached to. And like, it's hard to draw boundaries for any of these things, right? They're not like clear boundaries. It's like we're labeling a portion of a bone, right? So it's not gonna have a boundary. But what I would expect you to just kind of follow as a pattern is that the spinous process is gonna be attached to the lamina. It's not attached to anything else.
Okay.
The runs up and down, right? Superior to inferior, and it is between the pedicle and the lamina.
Okay, that helps.
And then off of the articular process is, or actually off of the lamina really, is going to be the thoracic, or the transverse process.
Okay.
I also sound like I've been doing this for like too long. Hopefully that helps. And if you're feeling like it's just mumbo jumbo, maybe take a break for today and see if it kind of makes a little bit more sense tomorrow. But
would you say that it's more important with this second? I felt like the first lab quiz was not too much identification, but I already feel like this like third chapter was, there were so many more pictures and like little parts.
That's a good question. I think that you can expect identification to be about the same amount in terms of like pictures, right?
Okay.
Because I'm just thinking logically, based on how many questions I know that we wrote that were picture wise, I think it was the same amount as quiz one.
Okay.
But I think that being able to like form the picture in your head will still be really helpful, because you're going to have to identify maybe which bone is next to the zygomatic, right? Or which bone like is this the sixth bone that was not named from the orbit. So you're still kind of like forming a picture in your head, but I don't think you're going to have necessarily more pictures on the quiz.
Okay. I think that's it. I think you're right. I think I need a break.
Yeah, I need a break too, Nicole. So that sounds like a good idea for both of us. But if you have any other questions, like I said, tomorrow I'm going to be in my office hours from 3 to 4. And you have 2 weeks to kind of get this information down. So if you have any questions before then.
Okay. Thank you so much.
Yeah.
Ecuna goes through. So yeah. Yeah, the sacral crest, that's solid. The coccyx, that's also solid. There's no openings there. Yeah, so there are 12 ribs in total, and we have the true ribs, which are 1 through 7, and the false ribs are 8 through 12, but the floating ones are specifically 11 and 12. There's only 2. Nice. So the costal vertebral joint, yeah. So the other one, the atlanto-occipital, y'all knew that. That's the atlas and the occipital bone where the skull is. Intervertebral, that is in between the vertebrae. And then sacroiliac, that's the sacrum and the ilia of the pelvis. I think keeping track of like these kind of joints is going to be beneficial because as we move on to the next one, which is the next lab, the appendicular skeleton, there's going to be a lot of other kinds of joints there. And then you start learning like what kind of joints they are, and they might take some of these joints from this lab to kind of like, I don't know, expand on that or like use it as an example. Also for muscles, that all connects too. So like paying attention to joints is really going to help you. Yep, so thoracic are known for that long downward sloping spinous process. And we know the lumbar one, their spinous process is like stout. That's what the lab manual likes to say. And then the cervical ones are like kind of long, but specifically sloping downwards is the direction for thoracic ones. Nice. Right. So you guys noticed that it was a cervical one because you can tell that there's those transverse foramen. Is that what that's called? Yeah, the transverse foramen. So that's something only the cervical vertebrae have. And then to distinguish if it's the atlas or the axis, you know, the atlas one doesn't have the odontoid process or the dens. And C2 is the same thing as the axis. Remember, this is the atlas bone, not the axis bone. All right, so for the atlas bone, right, it has no vertebral body. So the atlas and the axis are known for not having the vertebral body. And then because the atlas is the first one, it articulates with the skull. Only the axis has that projection called the dens, and the movement is not in the transverse plane because if you remember, transverse is this way, and then sagittal is this way. If you need help remembering the planes, I kind of think sagittal sounds similar to a saddle. And then when you sit on a saddle, you know, your legs kind of go over it like this direction, if that helps. But yeah, the saddle would split you in half this way, just like a sagittal plane would. it is the frontal and parietal. So the coronal suture goes this direction, and that separates the front, and then the parietal, or parietal, however you're supposed to say that. Temporal is the one on the side. Yeah. Last question. Yep, it's the mucous membranes. So I don't think Zara went too deep into you know, how air flows through it, but just in the lab manual, it just mentions how the mucous membranes do play a role in like warming up that air that comes through your nasal cavity. Oh wow, nice job, Emma. And Emily. Yay, good job, Andy. And good job to everyone who participated, because, you know, getting this kind of review is definitely going to help you understand like what to pay attention to. Okay. All right. But yeah, so that is the end for our Kahoot. Thanks for joining. Hopefully I'll see y'all next week. Or does anyone have any questions before we? No? Okay. All right. If you do, you can always shoot me an email.
Yeah. Thank you guys.
Thanks, Annie. Thanks, Zara.
Thank you.
Have a good week.
You too.
Thank you. All right.
Hey, thanks, Annie.
Oh, stress.
And then I clicked
That was great.